Hello, this is Mr. Kinyanola, and I'm going to help you find the surface area of a solid when you have information about two similar solids. So, as the instructions say, it says some information about the surface area and volume of two similar solids has been given. Find the missing value. So here we're trying to figure out the surface area of the second solid. So, remember that there are three types of scale factors. There is the linear scale factor, which is A to B. There is the area scale factor, which is A squared to B squared. And there is the volume scale factor, which is A cubed to B cubed. So the linear scale factor is how the sides compare to each other on a solid, or how the edges compare to each other on a solid. The area scale factor is how the areas change between the two solids. So remember, area, easy way to remember this is area is how many squares fit on the surface. So you take the linear scale factor and square it. Volume is how the volume changes as you change the linear scale factor. So quick way to remember that is you take the linear scale factor and cube it, because that's how many cubes fit inside of the solids. So what we're going to do is they give us both of the volumes. So we're just going to write a ratio. We're going to write 1920 or 1920 over 10,290. And what we're going to do is we're going to take our trusty old calculator and try to simplify that ratio. So it looks like both numbers end in a 0, so we can cancel those out, and that'll make our ratio smaller, 192 over 1,029. And let's see if we could simplify this some more. 192 divided by 3 is 64. Does 1,029 divide by 3? And it does. So we have 64 over 343. And it doesn't look like both of these have a common factor that we can get to simplify this some more. That's fine. Our goal is to get this to equal A cubed over B cubed, so we can get the linear scale factor. So, good way to do that, easy way to do that is to take your calculator. The first number was 64, so we're going to, opposite of cubing something is cube rooting. So what we're going to do is press the second button. Actually, not yet. We're going to press 3, and then press the second button, and then see that X with a square, with a root right there, or the radical symbol. Okay, so this is going to give us the cube root. And then we're going to just type in 64. And that's 4. So that means 4 times 4 times 4 gives us 64. So 64 is the same thing as 4 cubed over. Now we're going to do the same thing. We're going to type in 3, and we're going to press the second and this button where there's the X and the radical symbol. And then we're going to type in 343. And that turns into 7. So 7 cubed. So 7 times 7 times 7 gives us 343. So this is helpful because this right here, if we took away these cubes, would give us the linear scale factor. So our linear scale factor is for these two solids is 4 to 3. 4 to 7, sorry. The volume scale factor is 4 cubed to 7 cubed. And if you guys see a pattern, then the area scale factor would be 4 squared to 7 squared. So we're going to use this area scale factor to help us find the surface area of the second solid. So we're going to write this as, we're going to write a proportion now. 4 squared, instead of writing 4 squared, we'll use the actual number 16 over 7 squared, which is 49. So this is our area scale factor, is equal to, now we have to be careful. So this numerator is for the smaller solid, and so we know that solid 1 is the smaller solid because its volume is smaller. So we're going to take this 320 and put it in the numerator. And then we're trying to find the surface area for the larger solid, so we'll put x right there. Okay, and then all we're going to do here is cross multiply. So 16 times x is 16x is equal to 49 times 320, which is 15,680. And we're going to divide both sides by 16. So x equals 980 feet squared. So the surface area for the second solid is 980 feet squared. Hope this helps. Have a great day.